Let's start with section 3.4. We are going to start with rational zero theorem. It states if f of x is a polynomial function which has integer coefficients and an is non-zero, an is the leading coefficient. If p by q is a rational zero of the function, then p, the numerator, is the factor of the constant term a naught and q is a factor of the leading coefficient of a naught n. So what is a naught here? A naught is constant, and if there is a zero which is a rational number p by q, then p is a factor of a naught, and where an is the leading coefficient, then q is a factor of an, that is the leading coefficient. Let's see how we can use it. Suppose we have a polynomial function negative 2x raised to the power 5 plus 3x squared minus 2x plus 10. What is a naught? That is the constant term 10. What is an? The leading coefficient, which is negative 2. Let's write all possible factors of a naught. Factors of a naught are either, that is 10. So 1 is a factor, negative 1 is a factor, plus minus 2, plus minus 5, and plus minus 10. What are the factors of an? That is negative 2. So factors of an, which is negative 2, are negative plus minus 1 or plus minus 2. 2 has only two factors, plus minus is added, right? So if p by q is a root, a zero of the given function f of x, then p, the numerator, should come from these numbers, the factors of a naught, and denominator should come from these numbers, which are the factors of negative 2. So what are the possibilities? That means possible rational zeros of f of x are, what is the list? It can be plus minus 1 can be the numerator and 1 can be the denominator. So plus minus 1 or plus minus 1 by 2 or plus minus 2 by 1, which will be 2, or plus minus 2 by 2, that will be 1. So I'm not going to repeat the list. Plus minus 5 by 1, that will be plus minus 5, plus minus 5 by 2, plus minus 10 by 1, plus minus 10 by 2 will be plus minus 5, which I already wrote. So the question was just list. I'm not saying all these are the zeros. This is a list of all possible rational zeros of the given polynomial function. Let's do example 2. Finding the zeros of a polynomial. Now this rational zero theorem can be used to find the other zeros too. How? Let's start with applying rational zero theorem first. Note down your constant term, a naught is 2, and note down your leading term, that is leading coefficient, which is 1. So factors of the constant term are plus minus 1 or plus minus 2. Factors of the leading term are only plus minus 1. So possible rational zeros will be those where numerator comes from the factors of a naught and the denominator comes from the factors of 1. So what are the possibilities? Plus minus 1 by 1, which will be plus minus 1, plus minus 2 by 1, which will be plus minus 2. They are the only two possibilities. So that means possibilities are 1 or minus 1 or plus 2 or negative 2. So let's check. Let's check if 1 is 0 of f of x. How can we check that? Remember our synthetic division. Using synthetic division. That means I'm dividing my polynomial by x minus 1. So what are the coefficients? 1, negative 4, 3 and 2. I'm dividing by x minus 1 to check if 1 is 0. When will 1 be 0? If the remainder here comes 0, right? So let's go. 1 goes down. 1 times 1 is 1 here. Add the columns negative 3, multiply negative 3, 0 here. 1 times 0 is 0, add 2. This number is not equal to 0. So 1 is not a 0 of f of x. Let's try negative 1. Let's check x is equal to negative 1 is a 0 or not. Again, I'm going to do it by synthetic division. 1, negative 4, 3, 2. I'm going to write negative 1 here. 1 goes down, multiply negative 1. That will be negative 5. Multiply 5, 8, negative 8, negative 6. So this number is not 0. So we can say negative 1 is also not a 0 of the function. Let's try 2. Again, the synthetic division. 1, negative 4, 3, 2. Write 2 here. 1 goes down. 2, negative 2, negative 4, negative 1. 2 times negative 1 is negative 2. 0. We got the remainder is 0. That means x is equal to 2 is a 0 of f of x. We found 1 0, right? This is important. Also, we can find the quotient by, this will be x square coefficient, x and constant, meaning f of x can be written as one of the factor will be x minus 2 times the quotient, which is x square, minus 2x minus 1. So f of x, if you have to find the zeros of f of x now, we can say f of x equal to 0, meaning x minus 2 times x square minus 2x minus 1 is equal to 0, meaning either x minus 2 is 0, which will give x equal to 2. We already know that. Or x square minus 2x minus 1 equal to 0. This is simply a quadratic function. We can solve quadratic equation either by factorizing or by the formula. The formula you know is negative b plus minus b square minus 4ac by 2a. In this case, b is negative 2, so it will be 2 plus minus 2 square minus 4 times 1 times negative 1 divided by 2 times a is 1. So 2 plus minus square root of 4 plus 4 divided by 2. 2 plus minus square root of 8 divided by 2, which would look like 2 plus minus 2 root 2 by 2, 1 plus minus root 2. So all zeros of the function are 2, 1 plus root 2 and 1 minus root 2. So you see how we can find all the zeros using just the rational zeros theorem. Rational zero theorem just gives the possible rational zeros. Out of them we can eliminate. You can also use the calculator. Okay, so let's see. If we have a function, I'm going to show you how you can check. You can graph the function. Let's say in y, I'm going to write the function's polynomial, which is x cubed minus 4x square plus 3x plus 2. This is my function. I'm going to graph it. So you see approximately which one do you think the x-intercept? X-intercepts are the zeros, right? So we are saying the possible zeros are 1, negative 1, 2 and negative 2. So I don't think 1 is the zero. I can kind of cross 1 as a zero. Why? Because a graph is not passing through 1 and x-axis. I can cross negative 1 also. So I know it looks like the graph is passing through 2. So I can avoid checking 1 and negative 1 and directly check 2 also, right? That can also work. And when you know that the 2 is 0, then you can find the quotient part and find the zeros of that. That will give you all the zeros. Let's try one more example. So we have this function. Let's write its constant term. That is a naught is equal to negative 6. Find its factors. Factors will be plus minus 1, plus minus 2, plus minus 3, and plus minus 6. Write the leading coefficient an. In this case, it is 2. What are its factors? They will be plus minus 1 and plus minus 2. So, what are the possible rational zeros? They would be either plus minus 1 by 1, plus minus 1 by 2, plus minus 2 by 1 will be 2, plus minus 2 by 2 will be 1, which we already wrote, plus minus 3 by 1, plus minus 3 by 2, plus minus 6 by 1, or plus minus 6 by 2 will be plus minus 3, which I already wrote. So these are all the possible rational zeros. Okay, so we have a list of possible rational numbers. What I did, I took my calculator and I wrote my function 2x raised to the power 4 plus 5x cubed minus 2x squared minus 11x minus 6 in the calculator and graphed it. And I see it looks like maybe 1 is the 0, negative 1 is a 0, and maybe negative 2 is also a 0. So that gives me some idea. I don't need to try 1 because my graph is not passing through 1, right? So let's check negative 1. How do you check? X is equal to negative 1 is a 0 or not? You check using the synthetic method. Write the coefficients. Write negative 1 here. Add the column. It is coming to be 0. That means x is equal to negative 1 is a 0, and the quotient would be of the degree 3. So x cube, x square, x and constant term, meaning f of x can be written as x plus 1, that factor is coming because of negative 1, times x cube, 2x cube plus 3x square minus 5x minus 6. Now, when we graph, we also kind of think that negative 2 is a root. So maybe negative 2 is the root of 0 of the remaining quotient. So I'm going to write quotients coefficients now and check if negative 2 is a 0. Using the synthetic division, 2 comes down, multiply negative 1, 2, negative 3, multiply 6. It is coming 0. So we are going to say x is equal to negative 2 is also 0, and this is my quotient. This is going to be of degree x now, degree 2, that is quadratic. So f of x can be written as one factor is x plus 1, other factor is x plus 2 times the remaining quotient, which is this. Now we want to find the zeros of f of x, meaning f of x is equal to 0. So I write f of x equal to 0, either x plus 1 is 0 or x plus 2 0 or the remaining factor 0. I factored that out and got these zeros. So my zeros are negative 1 from here, negative 2 from here. So negative 1, negative 2, 3 by 2 and negative 1.